In this video, we will talk about viewing the rendered view of our beam model. When we run a simulation study for a beam model, we will notice that the plot view we get comes in a simplified form with a rod shape cross-section. For the stress plot, we can render that to the actual section of the model. To do this, we can simply go to the result plot, in this case the stress plot, right-click and click on Edit Definition, or we can also double click on it, and this will get us this menu here. And the first option we get under display is to render beam profile. If I click on that and then click on the green check mark, you will notice that the model will be rendered to represent the actual shape of the beam. This is a feature that is available for the stress plot. For the displacement plot, however, we are not able to do that. So if I switch to the displacement plot, right click and go to Edit Definition, we will notice that the option to render the actual section is not available here. So it is only available at the stress plot. While rendering the actual shape might get us more attractive close-up images, the practical value of the render can be questionable in different levels working with beams. And here are a couple of points to keep in mind in relation to this. 1. The mesh or nodes that SOLIDWORKS uses for the calculation is in the form of a line. This is because SOLIDWORKS simplifies it this way to make it easier to deal with long beams. Thus, the best way to look at the values is by looking at one cross-sectional segment at a time, rather than the approximated distribution the software might get you for different locations of the cross-section. The second point to keep in mind is that beams are by nature have a uniform cross-section, and thus calculations and changes in the design would most likely take that into account. If our design is more flexible, then it might be better to treat the model as a solid body in the simulation instead of treating it as a beam. In our case here, I don't really need to view the actual profile of the beam, so I'll go ahead and simplify it back. And by this, we conclude this video on rendering the beam profile.